students, this is Mrs. Carla, and I am going to teach you pre-algebra. Now, the very first lesson in pre-algebra is possibly already familiar to you, but that's okay. We have a lot of vocabulary that we're going to have to be learning and mastering so that we are ready for pre-algebra and then for algebra. So these are some things that we're going to be talking about. Number line, comparing and ordering, integers, classifying, sets, whole numbers, counting numbers, absolute value, and sequence. And some of those things you've already got up here. Some of them we're just going to be reviewing for you, and some of them maybe you're not so sure what they are. So I'm going to be going through and trying to explain everything so that you won't forget it. So this is a very foundational lesson. So when we're talking about, I might not talk about these all in order. You can see I have a line drawn on the board, okay? If I'm going to talk about the whole numbers, okay? Do you remember what the whole numbers are? Okay, if you were in a classroom here with me, then I would be picking out somebody who would be raising their hand, and hopefully someone would raise their hand and say, whole numbers are all the counting numbers and 0. Okay, so whole numbers, we'll write this down here, whole numbers are the set. Okay, so we're going to make our little set sign here. Set 0, 1, 2, 3, 4, 5, dot, 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 which means we continue on and on and on. Now, we call 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and on for infinity. We call those the counting numbers. Because if we're going to count something, we don't start at 0, do we? We start 1, 2, 3. Okay, so if I'm counting little objects, little balls on the board, I start with my counting numbers. So 1, 2, 3, 4. Okay, so 0 is how many elephants I have in my pocket, which is nothing, right? I don't have any elephants in my pocket. So the whole numbers have 0, and then all of the counting numbers. Notice that whole numbers don't have any negative numbers, which we will be talking about a lot this year, okay? So whole numbers include 0 and the counting numbers. So I'm going to make a little designation here, okay? The counting numbers are here. Counting numbers, okay? 1, 2, 3, 4. I'm going to lower this down just a little bit so you can see it. 1, 2, 3, 4, 5, dot, dot, dot. Those are the counting numbers. When I add 0 to it, I get the whole numbers. So we know what these are, and we know what these are. Okay, what are integers? Now, integers are when you get a little bit older after you've learned how to count and you understand the concept of nothing, 0, then you start to learn about debt, right? I owe my buddy $2 because he bought my ticket into the game last week, so I owe him $2. That means all of my money is not mine. I have to take the $2 that I owe him and give him back. So I've got to set aside that. If I have nothing but that debt, then I have negative $2, right? So when we start talking about the integers, we'll put another little number line up here. Okay, here's 0, 1, 2, 3, 4. These are the whole numbers. And the integers are when you take the whole numbers and their opposites. So -1 is the opposite of 1. and negative 2 is the opposite of 2, and negative 3 is the opposite of 3, and negative 4 is the opposite of 4. Now, the whole numbers and the counting numbers go on and on and on in one direction, don't they? They start at 0, the whole numbers start at 0, and they go forever and ever to the right. But the integers, okay, you have 0 in the middle. The integers go in both directions. Positive, 1, 2, 3, 4, those are your counting numbers. And then over here to the left are the negative counting numbers. Okay, so the opposite of all the counting numbers. So the integers go both directions on the number line. And you have, if you go forever in this direction on the number line, you're going to positive infinity. And if you go forever in the negative direction, you're going to negative infinity. Okay, so you can go to both infinities. And infinity is just the highest number, and you can never reach it because it just keeps on getting one more and one more and one more. Okay? Now, when I'm talking about so we talked about integers, okay? Integers are the whole numbers and their opposites, which includes negative and positive numbers both. Now, this right here, this long, nice line that's got arrows going in both directions, I call that my number line because I'm going to be placing numbers on it. Now, as I'm starting to compare and order my numbers, as numbers go to the right, they're getting bigger, and as numbers go to the left, they're getting smaller. So if I were going to compare 2 and negative 1, 2 is greater than negative 1 because it is to the right of negative 1. Okay? Negative 4 is less than 1. Okay? Because negative 4 is to the left of 1. So when we're comparing and ordering our numbers, we're thinking, where are they on the number line? Okay? So we've talked about number line and comparing and ordering. Now, when I am classifying numbers, I am deciding what kind of a number they are. Are they whole numbers? Are they counting numbers? Are they integers? Okay, and sometimes they belong in several of those groups. In other words, 3 is a counting number. I can have 3 bowls or 3 cups or 3 spoons, okay? 3 is a counting number. 3 is also a whole number because the whole numbers are the counting numbers with 0 added. And 3 is also an integer. Isn't it in the integer group of numbers? Remember, integers are whole numbers and their opposites. So 3 can be classified as a whole number and a counting number and an integer. Now, as we move further into our pre-algebra and into our algebra, we're going to be learning that there's a lot more categories of numbers besides just whole numbers, integers. We know that there's fractions and decimals. Okay, they're not integers. So we'll be talking about those later, those classifications. Right now we're just talking about the big ones. Okay, so that's what we mean when we say classifying a number. All right, and then what is a set? Well, I made a set right down here. This is the set of whole numbers. And you can see that this set down here is an infinite set. That means it goes on and forever and never stops. We can have finite sets or we can have infinite sets. If I were going to talk about the set of children that are my children, okay, I have 6 children and my children are 6, I would have 6 elements in the set of my children. Josiah, Lydia, Samuel, Daniel, Esther, Abigail. Okay, so 6 elements. That is a finite group. Now, finite just means countable. Okay, it doesn't keep on going forever and ever. It is countable. An infinite set would keep on going. Okay, I wouldn't be able to count them and stop and be done. All right, so a group is finite if it stops. So I could have 1,000 cents. All right, now that's a really big group, but when I get done with 1,000 pennies, I stop. So that would be the elements of my set, would be the 1,000 pennies. Okay, so my sets can be infinite or they can be finite. All right, this is an infinite set, and I can list the members or the elements of that set. All right, so we've talked a little bit about sets, and we'll have a lot more to say about those as we go on. And a sequence is what happens when we have a set of numbers that have a pattern and come one right after the next. Okay, so this is a sequence, isn't it? It is following 0 plus 1 is 1, plus 1 is 2, plus 1 more is 3, plus 1 more is 4. That is a sequence of numbers, one coming right after the other. My set of even numbers. Okay, do you know what the even numbers are? Even numbers. I could say the set of even numbers is equal to 0, 2, 4, 6, 8. Okay, now we'll talk more about those later, but this is a sequence. These are the positive even numbers. Okay, the positive, well, I'd have to take that one out if I'm going to make it the positive, right? So we're going to say positive even numbers. We have to take out 0 because it's not positive. So this is the set of positive even numbers. Notice that there's a pattern in my set. 2 plus 2 is 4 plus 2 is 6 plus 2. I have a pattern, and that pattern is plus 2 plus 2 plus 2. Okay, so this is a sequence. It goes on and on according to that pattern. Okay, so we know what a sequence is now. And the last thing that's on the board that we haven't talked about is the absolute value. The absolute value is very easily defined as the distance of a number from 0. Okay, now if I get into my car right now and I drive home, say it's 2 miles home. Okay, I drive home and I say that that trip is 2 miles. Well, if I turn around at home and I drive back here to school, then I would say, oh, well, that was 2 miles also. I don't say it's 2 miles in one direction and negative 2 miles in the other direction, because I'm still burning gas, right? No matter which way I'm going, it is a distance that I'm traveling. I am 2 miles from home. When I'm at home, I am 2 miles from school. A distance is an absolute value. Okay, so that's what I want you to think about. Now, when you're looking over here, I'm going to erase everything but absolute value. So we have just a little bit of room, and then I'm going to come back in a minute and we're going to work on problems so that we solidify all of these concepts in your head. Okay, when we're talking about an absolute value, I'm going to have a number in here. The absolute value of 3 is 3, because the distance that 3 is from 0 is 3 steps. Well, let's look. Here's 0, here's 3, and I would take 1, 2, 3 steps distance between 0 and 3. So the absolute value of 3 is 3. The absolute value, that's what the symbol means, of negative 3 is also 3. Okay, so when I look at negative 3 here, and I look at 0 here, negative 3 is 1, 2, 3 steps from 0. Okay, so what is the definition of an absolute value? how many steps from a number to 0. And that's it. That's all you have to remember. Okay, so now we're going to be back in just a minute with some problems to work for lesson number 1. So you stay on board. All right, here's some lesson 1 practice problems. It says arrange in order from the least to the greatest. So I have -4, 3, -2, 1, 0, -5. Now an easy way to do that is to jump down here to problem D, which says graph the numbers in A on a number line. So I'm going to make a little number line right up here. Okay, can everybody see that? Good. So we're going to have 0, 1, 2, 3, 4, 5, -1, -2, -3, -4, -5. Okay, now let's look at our numbers. We had a -4, which is right here. Put a little dot there to graph it on there. 3 is a +3, so it will be over here. -2 is going to be to the left of 0. It is a negative number. +1, well, that's over here. 0 is right in the middle. It is neither positive nor negative. And the last one is -5, way over here. Now, remember what we said. When we're ordering our numbers, we always want to make the least ones to the left and the greater ones to the right, just like our number line. So if we're arranging in order from least to greatest, we're going to pick the leftmost dot on our graph. Okay, so -5 would be the least number. So -5, comma, -4 has a dot, -2 has a dot, 0 has a dot, 1 has a dot, 3 has a dot. Okay, so 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. But now my same numbers are in numerical order from least to greatest. Okay, now look at this one. It says which numbers are even but not whole. Now we're still talking about the problem A up here. Which numbers are even but not whole? Remember, whole numbers are always positive. Negative numbers are integers, but they are not whole numbers. So remember, even numbers are divisible by 2. 4 is divisible by 2, but -4, although it is even, is not a whole number. Okay, 3 is odd. -2 is divisible by 2, but it is not a whole number. 0 is in the even category, okay, but it's not. It is a whole number, okay, and 5 is odd, 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 so we have the -2 and the -4. Now if we had, suppose we had a 6 over here. 6 is even, but it is also a whole number because it's a positive even number, okay? So now let's look at the second part of problem B. Which numbers are odd but not whole, okay? So since we're about to erase these, we'll put down here, this was -4 and 2, -4 and, can't see those over there, can you? -4 and -2 were the answers to this question. And now I'm going back over here and I'm going to erase that one because that was even. I'm going to erase this one because this one is even. And now we're working on this question, which says which numbers are odd but not whole. Okay, well, 3 is odd and whole. 1 is odd and whole. -5 is odd. It does not divide by 2, but it's not whole. So -5 would be the only answer to that question, -5. Okay, now compare. Remember, when we're comparing, we're using a greater than, a less than, or an equal symbol. Okay, so greater than, when you've got your little, I call it a bird beak. Okay, when you've got your bird beak open to the left, then the first number is greater than the second number. Okay, so is -3 greater than or equal to or less than -5? Well, okay, let's get a different color. So I have a red marker here. All right, so let's put a dot on -3, and let's put a dot on -5. I gotta erase the black dot and put a red dot now. Okay, so -3 is to the right of -5. Since -3 is to the right of -5, -3 is greater than -5. So I'm going to have my greater than symbol here, okay? And I always say the bird's beak wants to open up to get the biggest amount, okay? So when you're talking about your little beak here, you're going to gobble up the bigger number. And graph the numbers in A on a number line. Well, we already did that. So I will be back in a moment with some more examples. All right, here's another little set of problems for lesson 1. And up here we have absolute value. Remember, those two sticks mean absolute value of -5. And remember, absolute value is how far a number is from 0. Well, how far is -5 from 0? Okay, here's -5, -4, -3, -2, -1, 0. Okay, let's see how many steps they are. So 1, 2, 3, 4, 5 steps. 0 and -5 are 5 steps apart. Therefore, the absolute value of -5 is 5. What is the absolute value of 4? How many steps is 4 from 0? It's 4 steps from 0. Okay? Now, write two numbers that are 7 units from 0. Well, if we went 7 units to the right, we'd have 1, 2, 3, 4, 5, 6, 7. And that point right there has a coordinate of 7. A number that goes with that spot is 7, isn't it? Well, let's go the other direction. So here's 0, and we're going to go backwards, but we're still taking steps. Ready? -1, 2, 3, 4, 5, 6, 7. So since I'm going in the negative direction, that number is -7. So both 7 and -7 are 7 steps away from 0. So could we say that the absolute value of -7 is equal to the absolute value of 7, which is equal to 7. They're all equal to 7, aren't they? And the last one is write a whole number that is not a counting number. So a little riddle for you. What is a whole number that is not a counting number? Do you have it in your brain? Okay, think back to the definitions there. The answer is 0. Very good. Because 0 is the only whole number that is not a counting number. All right? So this is Mrs. Carla, and I hope you have enjoyed lesson number 1 of your pre-algebra book. God bless your day.